Are you ever hungry, but don't have anything to cook with? Well, I'm down at Capella, and I have your answer. Right here with the Scientific Cookware 3000. Right here, you got your wooden spoon. Then, you got your rubber spatula, and don't forget about your whisk. And you got your stainless steel drainer, your stainless steel pot, and your Teflon coated pan, and lastly, your Teflon coated bowl. My colleagues will show you how to use and what the meaning is of every one of these objects.
My name is Mustafa Ansari.
And I'm Jeff Ross.
And we're here to show you how to use this Teflon coated bowl, Teflon coated pan, stainless steel whisk, and rubber spatula
Let's make a delicious breakfast of scrambled eggs.
Turn the stovetop on to a medium heat. As you'll notice, on the stovetop, the heat starts to begin to warm up. The molecules get hotter and hotter on the stovetop, and the molecules move to the bottom of the pan. And when they move to the bottom of the pan, heat starts rising up and the pan starts to warm. First, we crack the egg in the Teflon coated bowl. Then, we add the milk. Add as much milk as desired. Lastly, we whisk it all together until it's a nice homogeneous mixture. By now, an endothermic reaction is occurring, where the butter is melting on the pan. The butter's melting point is 24 degrees Celsius. The stovetop is creating the energy, and the energy moves to the Teflon pan, and the energy in the Teflon pan gets moved up to the butter. The butter is heated up, and then we later add the homogeneous mixture, which is also known as the eggs.
First, we'll pour the eggs into the pan.
Giving the eggs a minute to turn into a solid, let me explain the change of matter. This happens because the amino acid chains break in the eggs due to the heat. As the heat is continually added to the eggs, all the water in the eggs start to evaporate out, and then the amino acids start to fold over one another, thus creating a solid.
Make sure to stir the eggs to avoid any burning. Once the eggs are finished, put them onto a plate. Voila!
Now here's to Jeff with a quick second.
We use a Teflon covered pan and bowl because they provide a Teflon covered stainless steel, which is called polytetrafluorethene. This provides a very slick surface, which allows the items we're using to cook with not to stick. We use a stainless steel whisk here because the stainless steel, due to its composition of iron, chromium, nickel, and other small traces of copper, carbon, titanium, and molybdenum, it avoids rust and decomposition that metal normally occurs. And lastly, we use this rubber spatula because due to rubber's latex properties it has in it, it prevents heat from rising up, which would cause my hand to burn.
By now you should know an energy transfer has just occurred. The energy transfer in this example is known as conduction.
Hi, I'm Lauren Novick, and I'm going to show you how to make noodles. First, we preheat the stove to the highest setting. Next, we fill our pot up with 5 cups of water. First, we place the pot on the stove. Then we wait for the water to boil. Now that the water is boiling, we can now begin to add the noodles. The water's boiling point is 100 degrees Celsius. Now that the noodles are in, we wait 11 minutes. Occasionally stir the noodles using a wooden spoon. We use a wooden spoon because it is not a conductor of heat. Once the noodles have finished, we pour them into the strainer. Finally, once all the water is drained, we move the noodles back onto the stove into the pot to cool down. And now you can enjoy your noodles.
As Lauren explained, we fill the pot up with 5 cups of water. The greater water volume within the pot will create more room for the excited H2O molecules to react. Once the water is in the pan, the stove is turned on, and the pan is placed on the burner. The pan reacts to the heat transfer because of its elemental composition of steel, which is iron smelted with coal. Metal is an excellent heat conductor because metal's atoms have some amounts of free electrons that can move easily to other atoms, which results to heat atoms moving throughout the pot.
But wait, there's more! If you buy in the next 10 minutes, we'll throw in this free microwave in a complimentary can of soup. This microwave uses radiation energy to heat the soup. It does this by heating the molecules and making them move around very quickly in the soup. This causes violent reactions and collisions in the soup, heating it. I'll prove this to you by putting my soup in. I'll set the microwave for 1:20. Wait for it. Voila! Now we have delicious soup thanks to the radiation energy of this microwave.